basketball player has a 70% chance of making a free throw, what's the probability they make exactly 4 of 6 free throws? So what is my N? How many free throws are being shot?
6.
X, how many do I want them to make?
4.
What is my P, the probability of making it? Okay, so this is one we could use on our table. So I have to go to when N is 6, down to when X is 4, and over to P equals 0.7. You need to have another sheet of paper and cover it up. If I need to put mine up here and explain how to read it, I will. I want everyone to try it and see if we get the same number. So what'd you guys get?
42.
Point what? Okay. So we could all read that from our table? Right. The next one. What is the probability that they shoot 8 times and make between 3 and 5 inclusive? So, N, how many shots are being taken?
8.
My P didn't change. The probability of making the shot is still 0.7. But what is X this time?
3 to 5.
Right, so it could be a 3, a 4, or a 5. So I'm going to have to get all 3 of those and add them together. So I'm going to, when N equals 8 on my table. So I'm turning the page. When N is 8, when X is 3, and go over to 0.7, and what do we have? Okay, and then you go down when X is 4, and when X is 5. Okay, so we add those together. And we get
0.436.
what's the probability they make less than 2 of 5 free throws? So what's my N? 5. My P is still 0.7. What can X be? So I'm going to have to get both of those and add them together. So I'm going to, when my N is 5, when X is 0, and P is 0.7. And we get, okay, and then if you go down to when X is 1, so if you add them together,
0.2303.
how are we doing with reading the table? Okay.
So how do you find the P?
This one it was given in the problem.
Well, I couldn't figure out how they were all the same.
Uh-huh. Yeah, I already scrolled down, I guess, when you came in. All right. I have another example that I added. So we're still doing this on our notebooks or something. A student gets at least 8 hours of sleep on 46% of nights. Assume all nights are independent. What's the probability they will get at least 8 hours of sleep on exactly 3 of the next 4 nights? So what is my N? What is my P?
0.446.
What is my X? Okay, go to your table. We have when N is 4, but I don't have 0.46 on my table, do I?
You have to do it by hand.
We have to do this one by hand. So, it's the formula. N choose x, p to the x, 1 minus p to the n minus x. So 4, choose 3.
Just.
What's wrong?
That
Oh. 0.46 to the third. 1 minus 0.46 is 0.54. And 4 minus 3 is 1. Alright, so I am just plugging this in my calculator. So you go 4, math over to probability, NCR. And what do we get? What is the probability they will get at least 8 hours of sleep 4 to 5 nights next week? What would my N be? 7. 7. So I went next week, so I'm talking about the next 7 days. My P is still 0.46. What can my X be this time? 4, 4, 5. So I have to do both. So we have 7, choose 4, 0.46 to the 4, 0.54 to the third, and 7 choose 5. 0.46 to the fifth, 0.54 squared. You're welcome to put the whole thing in at once or break it in pieces. I don't care.
Will we change the thing for, over the 54, or what would that be?
Yeah. So that exponent is always n minus x. So 7 minus 4 is 3.
Oh.
7 minus 5 is 2.
Okay,
Basically saying if 5 of the nights you did, 2 of the nights you didn't.
okay.
Do you guys understand how it works? So, use the table whenever you can. The cases when you can't would be if your probability isn't on the table or if your n isn't on the table, if n is too big. Then we use our formula. That's what the majority of the homework is asking you to do. Just read probabilities from the table, or if you can't, plug them in your calculator. Let's go to our notes packet now. We'll wrap that up and then give you guys time to work. So we are very close to being done with this.
Are we on the back page?
So graph the binomial probability distribution with n equals 8 and p equals 0.15. So we've drawn a graph before. We just did the most basic of graphs. We had our x's. If my n is 8, that means it could go up to 8. If you need to, if it's easier for you to read, you're welcome to put 0 over to the side, or you can actually put it right there. It doesn't matter. And then we're graphing our probabilities. Now, we could calculate each one of these, but we also have a table, right? Don't we have the probability distribution in front of us? So if n equals 8, and P is 0.15. Okay, so if I'm looking at those numbers, maybe I want to, it's like, the highest is 0.38, so let's do, alright, and then I'm just plotting each of these probabilities. So 0.1, when my n is, or x is 0, probability is 0.27. At 1, it's 0.38. Two is 0.23. 4.01, and then it gets really small after that. 5, 6, and 7 I can't really hardly even graph on my thing. Okay, so the purpose of this, really the only reason I would need to have that graph is if I asked you this shape. How would you describe that? What do you think would happen if I asked you to graph it when n is 8 and p is 0.85? Why? Yeah, isn't this just the opposite of 0.15? Let's look at it if we graphed it. So if I'm still on 8, but I go down to 0.85, the first few are 0, 2, 3, it's very small positive numbers, hard to graph. 0.01, 0.08, 2, 3. Do these numbers sound familiar at all? Wasn't that those were the exact same numbers we graphed up here, we just flipped them because the opposite of the complement of 0.15 is 0.85. And so when those probabilities are switched, or when the p is switched, it just switches the graph. This one is skewed left. Alright.
So when it says distribution, does it want the graph or want it skewed left?
If I said, I should have asked you for the shape. So the actual question just asked for the graph. Then I verbally said, tell me the shape. So. All right, the last little tidbit in this isn't something we're going to use a whole lot yet, but it will be a big deal in the next unit. In general, anytime n times p times 1 minus p is bigger than 10, the distribution turns out to be bell-shaped. Okay, the idea is when you get enough data, it always starts magically creating this bell-shaped graph if we have enough points. If that were the case, then the empirical rule can be used. We know unusual is anything with probability of less than 5%. So if you think about the bell curve, empirical rule says 95% of your points fall within 2 standard deviations of the mean, right? So that only means 5% is left to split over the 2 ends. So if you're in one of those ends, your probability is less than 5%. So anything outside of that 2 standard deviations is unusual.
And 3 is 97.5.
So that would be very unusual to be more than that. Alright, so last question. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. A researcher believes this percentage is higher than the percentage reported. He conducts a simple random sample of 400 car-owning households, find 162 had 3 or more cars. Is that unusual? Okay, so we could try it. We could actually calculate our probability and see if it's unusual or not. The other thing, if I asked you to use the empirical rule, because as it turns out, because my sample is so big, your calculator is going to have a hard time calculating this. But we could use the bell curve as long as our sample meets the requirements. What is my N?
400.
Okay, what's my P? Okay, what is my X?
162.
And I told you that if N times P times 1 minus P is bigger than 10, it becomes bell-shaped. So N times P times 1 minus P. And that gives me 91, which is definitely more than 10. So that means our graph is bell-shaped. So we can use the empirical rule. Okay, to do that, think about our empirical rule. I always looked at these graphs. My mean is, whoops. How do I find my mean? We should write that down. Think about yesterday. What did we say the mean was? N times P. So 400 times 0.35 gives us
140.
So if I were to draw a bell curve, the middle would be at 140. If I'm going to measure standard deviations, we need our standard deviation. So remember from Newstraight, that was the square root of N times P times 1 minus P. Square root of 400 times 0.35 times 0.65. That would be 9 point. We just make life easy and go to 2 decimal places. 9.54. So if I wanted 1 standard deviation from the mean, I have to do the mean plus and minus 9.54. And then 2 standard deviations. So if we add and subtract it again, 120.92. So anything between those numbers would be normal. We have a 95% chance of being somewhere between them. What did we get for ours?
Let's see.
162. Would that be unusual? Yes. 162 is out here. That's in this tail, and we know there's only a 2.5% chance of being in that tail. So it's more than 2 standard deviations. this is just another measure that we can use. In the cases where our sample is big, because if I just tried putting the original in, your calculator will freeze and it's just going to give you an error overflow message because the exponents are too big and it can't calculate it. So I couldn't just use my normal binomial formula because my sample got too big. So this is what we can do in that case. Alright, any questions there? We have the rest of the time to work on that pattern.